Hello and good evening by the time you're watching this. So we are going to go through the 2019 statistics paper. I've got the follow book right next to me so we can have a look at the statistical tables that are in the back of this. We can just go through it and we'll start on question number 1. So 3 bags A, B and C each contain 1 red marble and some green marbles. Bag A contains 1 red marble and 9 green marbles only. Bag B contains 1 red marble and 4 green marbles only. Bag C contains 1 red marble and 2 green marbles only. Sasha selects at random 1 marble from bag A. If he selects a red marble, he stops selecting. If the marble is green, he continues by selecting at random 1 marble from bag B. If he selects a red marble, he stops selecting. If the marble is green, he continues by selecting at random 1 marble from bag C. Draw a tree diagram to represent this information. Oh, good, of course, thinking of a tree diagram anyway for this one. So, tree diagram, as we know, we should be drawing tree diagrams with a straight line. Of course, on a screen, it's not easy to do, but I will give it my best shot. We've got a red and we've got a green. This will be 1 out of the possible 10. This will be 9 out of the possible 10. Because, again, we've got 1 and 9 in the first bag. Bag B, we're taking the green ones this time, and this time we've got 1 out of 4, so it'll be all out of 5, 1 out of 5, and 4 out of 5. And then down here we've got out of 3, haven't we? There, a third and 2/3. Red, green, red, green. Right. Part B. Find the probability that Sasha selects 3 green marbles. So 3 green marbles. In that case, we want the probability of 3 that are green, which means we multiply across the branches. So we've got 9 over 10 times by 4 over 5 times by 2 over 3. So essentially, in highlighter, we're looking for this branch times this branch times this branch. So that's going to give me 12 over 25? Yeah, 12 over 25. Right. We want, at this time now, find the probability that Sasha selects at least 1 marble of each colour. So we've got either the probability we get a green out of the first bag, times by the probability that we get a red out of the bag. We either get a green out of the first, and then a green out of the second, and then a red in the last one. And I think that's it. So, 9 out of 10 multiplied by 1 out of 5. 9 out of 10 multiplied by 4/5 times by a 1/3. What's that going to give you? 21 out of 30. Yeah, gives you 21 out of 30. Cool. Part D. Given that Sasha selects a red marble, find the probability that it gets selected out of bag B. Okay. So the probability that we get red is going to be a red out of first, so 1 out of 10. Then we've got a green out of A, and then a red out of B. Or the final case is we get 9 out of 10, we get a green, then we get another green, and then we get another red. What's that going to give you? 13 out of 25, does it? That's what it gives you. I think it does. Now, the probability that we take 1 out of B, remember, is the probability that we get a green from A first of all, and then we get the 1 out of the red out of B. So we're doing 9 over 10 times by 5, times by 1 over 5, which gives you 9 out of 50. So all we need to do now, to find what we want, we need to do 9 over 50 divide by 13 over 25. Well, multiplying by the fraction flips is going to cancel a lot of things for me. And it's just going to give me... what's that going to give you? 9 out of 25? I think. No, 9 out of 26, rather. Yeah, 9 out of 26 is going to get you there. So hopefully we're okay with question 1. Question 2. Okay, question number 2. Ugh, I hate box plots so much. Complete the box plot in figure 1 showing clearly any outliers. Right, let's zoom in a bit more so we can mark these on. So the first one is 7.6. Now 7.6 is all the way over here. 7.6, about there. And then we've got 8.1, so we got just after it there. Then we want the top end tail, which is 32.5, i.e. there in the middle. And then we connect the other one, which was 9.1, which was here. So we just need to draw straight lines between these two endpoints now. Some dodgy lines, but there you go. Part B. I'll take that off the screen. There we go. So, using your knowledge of the large data set, suggest from which month the two outliers are likely to have come from. Okay. Well, they probably would come from October. Now, this is only because if you know your large data set, it has the coldest temperatures. Yeah. Between May and October. In Beijing. Using the data from the large data set, Simon produced the following summary statistics for the daily mean air temperature, X degrees, for Beijing in 2015. We want to show that to three significant figures, the standard deviation is 5.19. Now, is this given to you in the formula booklet? Let's have a look. Yes, it is. It's for me. It's on page 8 in the formula book for Edexcel. Page 8, right at the top, standard deviation. It tells you what the standard deviation is, which is the root of sum of s of x over n. So that's literally all we need to do there. So we need to do the root of 4952.906 over n, which is 184. We'll do the square root of that. And funnily enough, that gives you 5.188. So to three significant figures would be 5.19. That's required. Right. Part D. Using Simon's model, calculate the 10th to 90th interpercentile range. We're given a normal distribution. So let's get the calculator. We're going to need it. We want the 10th to 90th. So we're looking in between the two. So we want to look at the 90% range, take away the 10% range. So on the Casio calculator, we're going to go to menu, go to number 7 for distribution. We're going to go to normal CD in this case. The upper value would be 10%, i.e. 0.1. Well, no, the upper value would be 0.1, rather. The lower value would be 0. The standard deviation is 5.19, and the mu is 22.6. Okay, doing that, it gives you a very, very small value, which you'd expect, because we're looking for the 10th percentile, don't forget. It gives you 15.94 on a load of other digits. So we're going to do the 10th percentile, in this case, is 15.94. The 90th percentile, we just need to do that as 0.9. Same old stuff. And we're getting 29.25, aren't we, for the 90th there? 29.25. So then all we need to do is subtract those together. So we'll do that quickly on the calculator here. 29.25 minus 15.94 gives you 13.3 to one decimal place. All right, the last bit then of this question says Simon wants to model another variable from the large data set for Beijing using a normal distribution. State two variables from the large data set for Beijing that are not suitable to be modeled by a normal distribution. Given a reason for each. Okay, well, the daily mean wind speed conversion as qualitative. Remember, qualitative literally means worded. Qualitative. And the other one is rainfall, i.e., there's lots of zeros in the data set. So that will muck up the standard deviation because essentially it's not a continuous variable, is it? Rainfall's discrete values of data. Okay, that's question 2. Moving on to question 3. Move down the page. There's a spare grid as well for question 2 for the box plot at the bottom if you needed it. Question 3, we've got product moment correlation coefficient. So lovely. So we need to state hypotheses clearly at the 5% level of significance, whether or not the product moment correlation coefficient for all countries is greater than 0. So, job number 1, we write down what the null hypothesis is, which means that rho will be equal to 0. The alternative hypothesis will state that rho is greater than 0, because that's what we want to prove. The critical value, then, this is where your final book comes real in handy. For me, it's right on the back, on page 20-something. I believe it starts on. Let me have a look. Yeah, so it's on. 37, sorry. We're looking for page 37, people. Page 37. Now we're told n is 24. So, in our final book, we're going to go down to 24, and we're going to come across to what we're testing here at 5% level of significance. So at 0.05, 24, and we get the value 0.348 is the critical value from the tables. Yeah, 0.3438 is the critical value. That's your CV, in other words. Now, if we draw a number line, 0.3438 is there. We've got 0.446. And we are told we want greater than 0. In other words, we want that bit. Now, the 0.446 is in the critical region. Now, it's in the critical region, so we reject H0 evidence to suggest there is positive correlation. And that will be a very quick hypothesis test. Part B, explain how this value supports Barbara's belief. Well, we've got 0.882, which is close to 1, so supports belief. Part C, show that the relationship between y and x can be written in the form y equals x to the power of n. Now, for this bit, I like to follow the way the textbook does it. So we've got log base 10 of y being equal to minus 1.82 plus 0.89 log 10 of x. People like going from this formula here to this one. Up to you. You can go from exponential to logarithmic, or you can go from logarithmic back into this form. That's the form I quite like anyway. So the 0.98 can come up to the power, and we can exponentiate both sides to get y equals. So we get y equals 10 to the minus 1.82 plus log base 10 x to the 0.89. So we can break this apart into two now. So we've either got now 10 to the minus 1.82 on the calculator is 0.015, and we're multiplying that by x to the 0.89. In other words, your a is 0.015 and your n is 0.89. All right. So it's just a little bit of logarithmic work there. Nothing too stressful though. All right. Doing good today, aren't we? Question 4. Let's move the page down, shall we? Okay. I'll give you a lot of paper for that, don't they? Jeez. Magali is studying the mean total cloud cover in octaves for Lucas in 1987 using the data from the large data set. A lot of large data set stuff on this paper, isn't there? The daily mean total cloud cover for all 184 days from the large data set is summarized in the table below. Oh, lovely. Find the probability that there is daily mean cloud cover of 6 or greater. Now, 6 or greater means we are including 6. In other words, we are doing these things added up and divided by 184. So, those divided by 184. I don't know what that's going to give you. Let me just quickly work that on the calculator. So, fraction bottom 52 plus 28 over 184 is 33 over 46 or 0.717. Just as a reminder, I'm using the Casio ClassWiz, the FX991EX calculator for all of my videos. I'll also be using the graphics calculator and the NumWorks calculator. I'm not using the CG50. I find it a bit clunky, and all my students will have the NumWorks calculator. If they can't afford it, then we have a set copy in school that people can use during our lessons. Just thought I would clear everything up there. But if I use a graphical calculator, I will tell you I'm using a graphical calculator. In part B, we're told that x is binomially distributed with a n of 8 and a p of 0.76. We want to use the model to find the probability that x is greater than or equal to 6. Well, that little formula that you mentioned that you learned in AS, which you do 1 minus the probability that x is less than or equal to 5, because you can only do less than or equal to on the calculators on the FX901X is the ClassWiz. On other calculators, this can become straight off. And if you just get it out straight off and you don't actually show this in this extra step, then that's totally fine. You get 2 marks for it. Menu into number 7, into scrolling down to binomial CD. We want variable. We're looking for 5. We've got 8 and 0.76. Which gives you 0.2967223407. So we'll do 1 minus 0.2967. So 1 minus the answer, which is 0.703. To reasonable degree of accuracy. I shall really do it 3DP. That should be plentiful. Part 2. Find to one decimal place the expected number of days in a sample of 184 days of that of 7. Right, well, there's actually not much I actually need to do here. All I really need to do is do 184 multiplied by the probability that x is equal to 7. and the probability that x is equal to 7, if you go into the options button on number 7 menu, you get binomial PD, which is number 4. Variable, once again, we want 7, and the n and the p stay as 8 and 0.76, they don't change, and that gives you 0.281 1877358, and you're going to go 184 answer, which is 51.7 days to 1 decimal place. Let me just write that down. Because to 1 dp, as the question says. Next bit. Explain whether or not your answers to part B support the use of the model. Well, 51.7, the bit that I just got there, 51.7 is approximately 52. So, support model. Remember, we're always giving it in context of the question, just to make sure we're covering all bases in our exams here. Part D, find the proportion of these days when the total mean calculus was 6 or greater. So we have to be slightly careful here that we're just adding 6 and greater again. So that'll be 1423 out of 28. I don't know what that is as a decimal. 23 divided by 28. S to D, and we get 0.821. You get 0.82142, but 0.821 to 3dp is plentiful. The last bit, comment on Magalhães model in light of the answer. Well, we all know that cloud cover depends on previous days. The binomial measures independent events. These are not independent, so not suitable. That will get you 2 marks. You're giving it in reference to the question, and then you're following up saying it's suitable or not. I would say a normal will be good for this, because it's continuous, and that does not measure independent events. So a normal would be good for this sort of question. Alright, moving on to the last question then. Let's move down to the bottom, which is here on question number 5. Got a machine puts liquid into bottles of perfume. The amount of liquid put into each bottle, d milliliters, follows a normal distribution with mean 25 milliliters. Given that 15% of the bottles contain less than 24.63 milliliters, find 2 dp the value of K such that the probability of 24.63 is less than D, which is less than K, is 0.45. A lot of information to take in, but we're going to standardize this, aren't we? So, let's draw a little diagram. Diagram, mean 25, 24.63 is about there, and we know that probability has 0.15. All we're going to do is standardize it. So Z is X minus mu over sigma, that little coding formula. Now that, as far as I'm aware, is not given to you in the formula booklet. I think that's one you have to remember. If I just confirm that for you. Yeah, you're not given it. You are given the one for when you're doing sigma over root 10. But you're not given this formula, so this is the coding that you got to remember. X minus the mean divided by the standard deviation. Mean of 0, standard deviation of 1. Again, we're going into menu number 7 once again. We're going to go to normal CD once again. We want 24.63, don't we? That's what we're looking at. But we want to do the inverse of it as well. So we're actually going to do the inverse normal to find what our area is. Because we're told it's 0.8 0.15, aren't we? Our sigma is going to be 1 and mu is going to be 0, so we get minus 1.036. So then we can do the coding on it. So 24.63 minus 25 over sigma. It's going to give us that. Bit of calculator work, and it gives you 0.356 on a load of the digits. From that, we can then get that the probability that D will be less than K is 0.6. Purely because if you draw where K is, which is about here, this bit will be 0.45, which is what we're looking for here. When we add on the 0.15, that's going to give you 0.6. So we can do some more coding, and we can then look for 0.6. And funnily enough, when you do that, you get 0.253. So we can do the same coding, and then we can set up our little equation, and we can find what K is. That's the plan of attack with most of these. At first glance, the question looks horrific, but actually, all it is can you set up equations with the coding data with a standardized normal distribution, which is what this is called, if you were wondering. This is called the standard normal distribution, where we usually call it Z, actually. So we're doing, it's going to be K minus 25 divided by the sigma, which we now know is 0.356, equal to 0.253. So we can get the value of K out there, and that gives you 25.09 to 2 decimal places. Alright, part B. So, normal approximations, we always know that Y, we know follows a binomial at the moment of 200, 0.45. Got N is large, P is close to 0.5, so this stands. We can rewrite this as W follows a normal, let's say, of N times P, so 200 times 0.45, well, that's quite quick, that's 90. And then we're going to times it by 0.55, because it's NPQ, remember the formula. So we're literally just going to do 90 multiplied by 0.55, which is 49.5. So it's 90, 49.5. We want less than 100. So fewer than half of 200. Should be 100. However, we need to include the continuity correction, which in this case will give us W is less than 99.5, just to make sure we get that extra bit in there. And then doing that on the normal button on your calculator, so number 7, normal CD again. We want less than 99.5, so 99.5 is our upper value. The lower value can be, I don't know, I always pick minus a million, that always does it for me. Our sigma in this case is root 49.5, being slightly careful. And the mean is 90. And that gives you 0.911535491. So we'll go at 0.911 to reasonable degree of accuracy there. The last bit, we're doing a hypothesis test, so we'll put that on a new page, let's say. We'll also just bring the screen down a little bit so I've got a bit more room. So the hypothesis test goes, we set up what the mean is, which is H0, which is mu, which is equal to 25. The alternative, H1, is that rho is less than 25, as it says there. So we can do D bar is normally distributed with 25, comma. Now this is where that formula is that's in the formula book, is on page, let me find it. It's right at the bottom of page 8. Well, I say at the bottom, it's more in the middle. So it says for Normal distribution means sigma squared x bar minus mu divided by sigma over n. What will give you the coded one there. So it's just remembering it's sigma divided by n here. So it's 0.16 squared divided by n, which in this case is the 20 that we've got there. So we can look at the probability that D is less than or equal to 24.94. That's nice and straightforward on our calculator. We're going to go into good old menu number 7 again. We want less than 24.94. We've got a sigma this time of the root of this, which is being slightly careful. It's the root of 0.16 squared over 20. And the mu is 25. And that gives you 0.04676625636. So 0.0467 then will do for the time being. However, if we draw a quick normal distribution, our mean is here, this is mu. We got 24.94, which is just about here. 0.046 is this bit here, that's what that is. And 0.05 is just over that boundary line there. So we can reject H0, and we can say there is clear evidence to support Hannah's belief. Or, in other words, if you want to write it slightly different, 0.0467 is clearly less than the significance level of 5%, and hence you can do the old reject the null hypothesis. There is evidence to support Hannah's belief. Alright, that is your 2019 statistics paper. I hope you enjoy this, and I hope it's a bit better with me telling you what I'm plugging into my calculator. If you find that useful, do let me know and have a look at the mechanics one that I uploaded not long ago, if you want to look at the other half of this paper. If you want to do any other stats on mechanics papers, I can do 2018. In fact, no, I've done the 2018. You can have a go at that. If you want to pull out any of the specimens or the sample papers for stats and mechanics, I will happily give those a go. We can go through these together. And the exams, good luck for Rising Fallen in about 3 months' time. So let's nail these, guys. Thanks very much for listening.